All right, we are going to finish up section 4.6 today. Our focus is on this new topic called completing the square, and it's another technique we can use to solve quadratic equations. So this is our fourth method. This is what we can use if we don't have a perfect square trinomial. So remember yesterday we had things like x squared plus 10x plus 25 equals something. And this left side was a perfect square trinomial that we could factor down just the way it was into two identical factors. Well, today we're going to look at what happens if we don't have that. So our first step is to get the constant on the opposite side of the equation from the x's. So I'm going to move the 1 to the other side by subtracting it over. Our second step is that we're going to add something to complete this, to turn this into a perfect square trinomial. We need to figure out the perfect number to go in there. But if we add something to the left, we have to remember we always add it to the other side as well. Now, to figure out what that missing number is, we use this equation. C equals b divided by 2 squared. And remember, your a is the number in front of your x squared term, b is the number in front of x, and c is your constant. So we've moved the constant to the other side, and now we're trying to find a new constant to put in there that will make this factor nicely. To find that, we take b divided by 2. So our b value was 4. So we're going to take 4, divide it by 2, which gets us a 2. And then we're going to square that. And 2 squared is a 4. So the missing number we want in there should be a 4. Again, whatever we add to one side, we have to add to the other. Now the left side has turned into a perfect square trinomial. So we are going to be able to factor it down into two identical factors. On the right side, we take -1 plus the 4, and we get a 3. Now to find those factors, you are always going to have a factor of x plus or minus that b divided by 2 piece. And when we took b and divided it by 2, we got a 2. So that's what it's going to factor down into, x plus 2 quantity squared. And you can always check it. If we take x plus 2 and square it, we end up with x squared. 2x plus 2x would be 4x for our insides and outsides. And our last term, 2 times 2, would be the 4. So it does work. And now we're going to use the same technique we used yesterday, and that was to just square root both sides. So we end up with x plus 2 equaling plus minus root 3. There are no perfect squares inside that 3 that we can pull out. So all we can do is just move the 2 to the other side by subtracting it. So our answer would be -2 plus and minus root 3. So once we get it completed, once we do the completing the square step here, this main new step, which was to find that c term, once we do that, we've turned it into the type of question we had yesterday. All right, let's try another one. We have x squared minus 6x minus 3. Again, the constant here is almost always not the right one, so just move it to the other side. We have x squared minus 6x, leave a space, equals a positive 3 if we add it to the other side. Now I left a space because remember we're going to complete the square. We're going to find that constant that's going to make this work. So we're going to take our b term, our -6, divide it by 2, and square it. Well, dividing it by 2 gets us -3. Squaring it gets us a 9. So we want to add 9 to both sides. So we have x squared minus 6x plus 9 equals 12. Now we have created on the left side a perfect square trinomial. So it should factor nicely. One second here. So it does factor nicely into two identical pieces. It's always going to go back to x and then whatever sign we had here and half of our 6, so our 3. Again, it's always going to go back to that b divided by 2 number. And now we can square root both sides. And simplifying on the left side, we have x minus 3. On the right side, we want to break down that 12. So we can think of it as 4 times 3. When we square root that, we get 2 root 3. Don't forget your plus minus in front. And then your last step to solve for x would just be to add 3 to the other side. So 3 plus and minus a 2 root 3. All right. So note that the x squared term cannot have a number in front of it other than 1. So no coefficient in the front. If it has one, we have to divide both sides of the equation by it, and then we can continue that completing the square process. So if we were to start looking at this one, notice that we have x squareds on both sides. We need to get those together. So I'm going to subtract the 2x squared over to this side. 1x squared minus 2x squared would be negative x squared. Now, we have a number in front of our x squared that isn't just a 1, it's a negative 1. So we have to divide every single piece by negative 1. Our first term becomes a positive x squared now, which is what we need. Our second term becomes a positive 8x, and our third term becomes a negative 4. 0 divided by anything is still 0. And now it's the type of question that we can complete the square. So we're going to bring the negative 4 to the other side, leave a little space where it was, so that we can complete the square. We can figure out what that missing number should be. Remember, to find that missing number, we take b divided by 2 and square it. So our b term here is an 8. 8 divided by 2 is 4, and 4 squared is 16. So 16 is the missing number that I need in here. The left side now is a perfect square trinomial. It factors down into x plus 4 quantity squared. Again, remember, this number is always going to be half of your b term. On the right side, 4 plus 16 would be 20. We can then square root both sides, and we end up with x plus 4 equaling, if we split this into 4 times 5, we're going to get a 2 root 5. Our last step then is just to subtract the 4 to the other side. All right, our next example. Notice that we have a 10x on the other side. We need to move that over with the other x squared pieces. So I'm going to subtract 10x back here. We have 2x squared minus 10x minus 6 now is equal to 0. We cannot complete the square when there's a 2 in front, so we have to divide everything by 2. That turns it into x squared minus 5x minus 3 equals 0. All right, to complete the square, we need to add 3 to the other side. And we need to figure out our missing number. Now this one is a little more difficult because we have a 5 in the middle, or a negative 5, and we have to cut that in half. It works out great when your middle number, your b term, is even. It's easy to divide it by 2. In this case, not quite as easy, but we can still do this. We want to take b divided by 2 and square it. Since it's going to come out as a decimal, I'm just going to leave it like it is as a fraction and square it. Negative 5 squared is 25, and 2 squared is 4. So I'm going to add 25 fourths to both sides. When I go to factor the left side, remember it always factors down into 2 identical factors, and it's always x plus or minus, whatever our middle sign is, half of our b term. So it's just going to go back to that 5 halves. On the right side, I'm trying to add 3 and 25 fourths. In order to add these, I need to think in terms of common denominators. So 3 is the same as 12 fourths. I'm adding 25 fourths to that, so I get a total of 37 fourths. I then have to square root both sides. The left side just cleans up into this x minus 5 halves. The right side, we get plus minus. 37 doesn't have any perfect square factors that I can pull out. So I'm going to just leave it as the square root of 37. But I can square root the 4 on the bottom to be just a 2. Then when I add the 5 halves to the other side, it comes out a little easier because we have a common denominator. So I have 5 halves plus the square root of 37 halves. Okay? So the last thing that we're going to look at this for today is we can use this process of completing the square to take an equation that's in standard form and convert it into vertex form. If you think back to the beginning of the chapter, we looked at graphing them in both forms, and typically graphing in vertex form was a little easier. So this is a process we can use to convert them from standard form, which is what we have right here, that ax squared plus bx plus c, from standard form into vertex form. So our process, again, we're going to move c to the other side. So this -1 I'm going to add over here. So all I can do is say there's a y and a positive 1 on that side. I can't really put them together. On the right side, I have x squared plus 10x. Then I'm going to do that whole completing the square process. I'm going to figure out the missing constant. Whatever I do to one side, remember you have to do to the other. So we're going to take half of 10 and we're going to square that. So half of 10 is 5. 5 squared is 25. We're going to add that to both sides. The left side then would simplify to be y plus 26, and the right side is now a perfect square trinomial, so it factors down into x plus half of our b term squared. And then the last step would just be to subtract the 26 back to the other side. So now it is in vertex form, and we can identify the vertex. This is a transformation that's moved left 5 and down 26. So our vertex would be at -5, -26. Okay, now it didn't ask me for the vertex, but that's why we do this, so that we can convert it to vertex form. Easy to find that vertex if we need it. All right, let's try this again. So step 1, remember, was to move the constant to the other side. So we're going to subtract it over here. It's just going to hang out with that y for a few minutes. And then we're going to complete the square. We're going to figure out what that missing term should be. So we take our -8, our b term, cut it in half, and square it. When we cut it in half, it's -4. Squared becomes 16. So 16 is my missing number. And the right side, remember, always factors down into x and then that half of b term. So half of -8 is -4. On the left side, we have y minus 3 plus 16 would be plus 13. And then once again, we can just subtract the 13 over to the other side. So we can now locate our vertex. Our vertex would be at 4, -13. All right, go ahead and pause the video and try the next one. All right, let's check what you did. Step 1, you should have subtracted the 7 to the other side. Then you should have completed the square, figuring out what's that missing piece. So we take our b term, -6, cut it in half, which would be -3, and then square that, which would be 9. So you should have added 9 to both sides. The left side then becomes y plus 2. The right side is now perfect. It factored down into x minus 3. And then simply move your 2 to the other side. Subtracting it over would make it a negative now. So our vertex for this one would be at 3, -2. All right, so the last one that we're going to look at, notice that there is a coefficient in front of our x squared term. There's that 2 there, and we don't want to have a 2 there when we complete the square. So what we're going to do is we're going to get the 10 out of the way. We're going to subtract it over. And typically we would say we're going to divide both sides by 2. But easier, since we really are wanting this to look like this, right? That's our vertex form. We really want that number in front of our squared piece. So we're going to just kind of factor it out of this side and leave the x squared minus 8x, which is the type of expression I want when I'm trying to complete the square. Now, we have to complete this piece. Half of -8 is -4. When we square that, we get 16. So we're putting a 16 here. But be careful, because what we really put in here is 2 times that 16. So I really added a 32 to that side, even though it doesn't look like I wrote that. So I have to add a 32 to this side. In other words, the 2 times the 16 piece. All right, completing this, we have y plus 22 on the left side. On the right side, it factored down, I'm sorry, I see my mistake here. I didn't cut the 8 in half. All right, let's go back and try this again. Okay, so we said we were going to factor a 2 out of the x squared minus 8x piece. So this should have been a 4x. I apologize for that. All right, so now we're going to complete the square. Half of -4 is -2. Squared becomes a 4. So I really need to put a 4 in here. But what I've added to that side is really an 8 because of that 2 that would get distributed to it. So I have to add 8 over here. This now becomes y minus 2 equals 2 times what I can now factor down into x minus 2 quantity squared. And then I can add the 2 to the other side as my k term. All right. So transformations, if we were going to talk about transformations for this, we'd have a vertical stretch of 2. We would shift right 2, and we would move up 2. Okay, so homework for this should be a Delta Math assignment.